Hello guys, welcome back to my channel. Memo African Motives. Still working on engineering science and working on mechanical drives and lifting machines. So we still have some parts that we worked on from the previous question papers and so on. So this is actually a continuation of previous topics that we had. This time we are given on question 5, and it's actually, that's what we have there. So guys, if you're new, you can consider subscribing so that you become part of the family Memo African Motives, as we shall be working on engineering science N2 and also mathematics N2. So let's just quickly rush through the question, guys, that you're given. The first question is to state 2 advantages of gear drives. Okay, so there I just listed some of the advantages that you can have on gear drives. Remember guys, advantages: they use smaller space, there is more torque, that is more power, less maintenance, and there is actually no slip there. So these are the advantages that you can obtain when you are working with the gear drives. Okay, so that was 5.1 there. Then 5.2, there's something important there. The compound gear train in Fig 4 below shows 4 gears. Gear A has 60 teeth. Okay, so this is gear A with 60 teeth. All right, then others were given. So this is, as we know that this part here, B and C, is coupled together like this. So we are going to maintain the same speed. I talked about this previously. I think now we can relate to the diagrams that I was drawing some time there, that they are just similar to this one a little bit. All right, so the first question is calculate the rotational frequency of gear A in revs per second. Okay, so this part, guys, we are given A and B, so these two we can relate to them. Okay, so how do we relate, guys? Okay, this is actually 5.21. okay, so we can relate from the number of teeth and also the speed that we are going to have, which is the rotational frequency. So how do we connect this? TA NA is equal to TB NB, just like that, guys. That's how you connect this. Easier, and you've been talking about this. I think now you are very familiar to this one. So we need NA, you're just going to divide by TA. So our NA is going to be TB NB over TA. You divide by TA. So you just substitute into the formula there. That's TB, which is on B, we have got 75 teeth there. TB 75, NB, that is 140. So it's 75 times NB, that's 140 over TA. Okay, on A we have got 60 teeth there. TA is 60. All right, so from your calculator, this is going to give you something like 175. Okay, so this is actually NA, which is the speed. So it's going to be 175 revs per second. Remember, the other one was in revs per second, so definitely this one is going to be in revs per second. So that's how you determine this, guys. Okay, the number of teeth on gear D, if gear D is rotating at 340 revs, as you can see, gear D is rotating at 340, but we need the number of teeth. Okay, so what are you going to use here? Remember, these two are supposed to work hand in hand, but here we are only given the number of teeth, and they are asking this same question but in different ways, guys, if you are to cross check. So remember, I told you that since these two are connected to each other, they are going to be, this is going to rotate with the same speed, because these are actually coupled together, they are connected together. So the speed on B is the same speed, which is the rotating frequency on B, is the same rotating frequency which we have on C, because they are coupled together. Okay, so that is the first thing that you're supposed to indicate. So the first thing that you're supposed to indicate is that NB is equal to NC. These ones which are connected together, these ones, B and C. So if they are equal, it means NC is equal to 140 because NB is 140. So this is equal to 140 revs per second. Now we can use the same relationship which was between A and B, same relationship between T and C, between C and D, C and D. So it's going to be T, C, NC, which is equal to TD and D. Now it's a relationship between C and D. So what do we want? We want the number of teeth which is on D. So we are going to divide by ND. So that means TD is equal to this part divided by ND. So it's going to be TC, NC divided by ND. Okay, so you just substitute here. TC you are given is 110. So this is going to be 110 times NC. The one that you were not given, are you seeing that was not given, but we know that it's equal to NB, so you're going to take 140. That's just like that, guys. Okay, over ND. On D, we are already given the rotating frequency, which is 340 revs per second. So that's 340 there. So the moment we do this, our TD is going to be this decimal, guys, but let's see how it's going to end. First, let's just write the decimal. That's 45.0. Is it 20? Is 2? 45.29417, something like that. Okay, but these are number of teeth. Therefore, referring to number of teeth, guys, we'll be talking of a whole number. It's not about speed. Speed can be a decimal, but the number of teeth, we can't have 45.2 teeth or 45.3. It's a whole number, so 2 cannot round off this 45, so it's going to remain as 45 teeth. So the number of teeth there is 45. So that was the platform, guys. That was the question, and we are done with that. Okay, then on 5.3 we are given that the ratio of force of the tight side to the force in the slack side of a drive belt is 4:1. Okay, remember we talked about belt drives, different types in fact that we can have, and how do we write them and how do we present them. Okay, so in this case we are given a condition where we have got the tight side and the slack side. Remember that the tight side, guys, from our presentation is given by what? By T1. I hope you still remember that. On belts, T1, that's your tight side. That's your tight, and T2 is your slack. If you maybe you don't understand this, but we are going to talk more about this maybe to do a class that is gonna actually focus on belt drives. Not from question papers, but a class actual. Okay, so we are given the ratio is tight S2, which is 4:1. So which means T1, remember a ratio can be given as a fraction, which means T1 over T2 like this is equal to 4. That's a ratio. Or it can be T1 S2 T2, which is equal to 4:1, just like that. So it means you can formulate something like this to say that T1 is equal to, if you cross multiply, because this same is like over 1. So if you multiply here, 1 times T1, that's T1, 4 times T2, that's going to be 4T2. So it can be written like this, or it can be written like a fraction. So that's how you write a ratio there. Okay, then we are given the force on the tight side is 600. So we are given T1 in this case. T1 is 600 newtons. All right, then the belt velocity, we are given the velocity of the belt, which is 20 meters per second. All right, so that's what we got, guys. Let's do this now. What are we given? What do we want to do? Okay, we don't know what we want to do. This is what we want to do. Calculate the following. 5.31, the force on the slack side, which means we are calculating 2 there, which is T2. Yes, you can write this as T, guys, or it's just actually just like tension, something like that. Okay, so you can write it as T or F. Okay, so from this ratio, T1 is equal to 4T2. So T1 is 600 is equal to 4T2. So to find T2, you're going to divide. Remember I said T2 is the slack, so you divide by 4. So this is what you're going to have. T2 will give you something like 150. So that's your T2 there. So you've got our 5.31. Okay, and not about 5.32. What are we given to find here? The effective force. Okay, remember guys, we talked about the effective force also, that the effective force is the difference between the tight side to the slack side, T1 minus T2. So our T1, that's 600 minus T2, which is 150. So the difference there is your effective force, which is a difference of 450 newtons. All right, so you've got the effective force, which you can write as Fe. Then the last question to achieve the total of 11 there was the power transmitted. Okay, so this power is nothing else because we got the effective force and we also have got the velocity here. So this one is not going to be much because we know the relationship between the effective force and the velocity, that when I multiply these two I'm going to obtain the power. So simply multiplying the effective force of 450 multiply by the velocity, which is the velocity in this case is 20 meters per second. So you're going to multiply by 20 meters per second. By doing this, you're going to find the power, which is 9,000 watts. So remember, power is measured in watts. So you can write this in watts, or you can convert this to kilowatts. Divide by 1,000, you're going to obtain, which is 9 kilowatts. So it can be at this stage, or it can be like this. So that's how, guys, they ask these questions. Actually, if you are to see on working on mechanical drives there and lifting machines. So just like I said, we are going to at least have a class that we are going to do before we write, just mentioning more, like having notes on this part and also having notes on belt drive, because we talked about this only in question papers. We didn't like have a class that we focused on these areas. So that's what you're going to do before we write, guys. So just a reminder on the comment section for any topic that I'll be uploading, so that I will know that we still have something to work on. So that's it, guys, from Memo African Motives, working on engineering science N2 and also mathematics N2 and also other questions from question papers and so forth. Till we meet again.